Yes, so as Benta said, well, I'm working for the Open Geospatial Consortium, and I am involved in NextGEOSS, where I am in charge of engagement, and also in eShape, where I am in charge of coordinating the implementation of the 27 pilots. And right now in eShape, we are assessing the pilots, where they are and where they plan to go to coordinate the developments. And in NextGEOSS, we are preparing the sustainability. And what I have seen is that OpenSearch is a really good candidate open API to connect the different components of the GEOS. And this is what we try to push and raise awareness out of these two webinars we are making. Last week it was about compliance, and here it's more a focus about OpenSearch. So I would like to begin just by a little bit of history to explain what is OpenSearch and where we are going and why we think it's a good candidate for this type of system of systems. So the OpenSearch specification originated in the community, in a community effort built around the Amazon subsidiary A9.com in 2005. It is licensed under the Creative Commons Attribution Share Alike 2.5 license. The OpenSearch Query Protocol is a collection of simple formats for the sharing of search results, allowing to syndicate those search results to a variety of applications that support these open standards. The OpenSearch description format allows the use of extensions that allow search engines to request a specific and contextual query parameter from search clients. And the response elements can be used to extend existing syndication formats such as RSS and Atom with the extra metadata which is needed to return search results. So this standards supports extensions, as I said before. And in 2014, OGC has published the OpenSearch Geo and Time extension standards to the OpenSearch Query Protocol to provide a very simple way to make spatial and temporal queries to a repository of geospatial content that contains geographic and temporal properties, and to allow simple syndication of repositories. So these specifications, which is the name of our specifications have a number, so a name and a number. So it's the OpenSearch Geo and Time extension, OGC 10.032 release 8. It codifies those extensions in a form which is compatible with the other OGC standards baseline, and incorporates feedback from developers in the open source geospatial community. So it's completely compatible with OGC standards and the previous OpenSearch works. Yeah. It is recommended for spatial and temporal queries, specifically for Earth observation collections and Earth observation product metadata. Further, it defines a default response encoding based on Atom 1.0 and XML. So it is complemented by the OpenSearch for Earth observation, OpenSearch EO, OGC 13.026 release 8, suite of standards that updates the extensions primarily to include additional examples for developers. This OpenSearch for EO extension is quite a success story, as it is implemented for hundreds of Earth observation data series from all over the world, federated by NASA, ESA, CEOS, GEOS, etc. So, but of course, you always have still room for improvements. So recently, further, 2 new encodings for OpenSearch EO conceptual model have been developed as a new standard, one for encoding metadata using GeoJSON or JSON-LD, and one for encoding the responses to OpenSearch EO queries in GeoJSON and GeoSLD. So works are still going on, but these standards are already very implemented and very used. And the goal of this webinar is to show that it is successful and usable by projects right now, not only by data providers, but also as an open API to build a system of systems. And just a last word, because now when I will talk about standards, I will try to explain how they relate to the data management principles. So this standard, because this is, I think, a webinar we will have to do later, this standard contributes to findability, access, and interoperability in the FAIR reference for data management. And for the geodata management principles, it relates to discovery, accessibility, and usability.